Hello everyone, this is Professor Vaibhav Shah and our today's topic is projection of points. So now let us start. So now for any orthographic projection, either for points, lines, planes or solids, to draw projections of any object, one must have following information. A. Object with its description well defined. Means with its size and shape like square, pentagon, hexagon. In our case, object is point. B. Observer. Always observing perpendicular to respective reference plane. Like HP and VPs, you will be observing at 90-degree direction to your reference planes HP and VP. C. Location of an object means its position with respect to HP and VP, either in first quadrant or second quadrant or third quadrant or fourth quadrant. Now, terms above and below with respect to HP will be used, and terms in front and behind with respect to VP will be used. Here we will be forming 4 quadrants. Objects can be placed in any of these 4 quadrants. Now let us study the illustration by taking point A as our object. So let us start. Now before moving ahead, we must understand the notations. Now following notations should be followed while naming different views in orthographic projection. So our object is point A and we can have 3 views: top view, front view and side view. So now let us first define its top view. So its top view will be defined by A, small a. So as your point, you can see your point is capital A. So we can define our top view by small a without any dash. Its front view would be defined by small a with a dash. And its side view would be defined by A with double dash. So now let us start. So before moving ahead, we must understand the quadrants. So let us understand this quadrant system. So now as you can see, there are 2 planes. One is your horizontal plane, which is known as HP, and another is your vertical plane. So let us first define these 2 planes. First, horizontal plane. So plane which is parallel to your earth crust or earth surface is known as your horizontal plane. A plane which is perpendicular to your horizontal plane would be known as your vertical plane. Now by intersection of these 2 planes, we are having 4 quadrants, namely first quadrant, second quadrant, third quadrant and fourth quadrant. Now if we put object in this first quadrant here and if we try to observe it from this direction, so let us see, we are observing object from this direction. We can have the object's front view on your vertical plane here. So let us take the front view here. Now if we observe the object from its top direction, we can have its top view here in HP. So always remember, whenever you are taking front view or top view of any object, you can have its front view always on the vertical plane and your top view of any object on your HP, means horizontal plane. Now let us take the view of this quadrant system from this left hand side direction. So as we can see, this quadrant system will look like 1 plus, doctor's plus, and at the center we will be having this point as XY point at the center. So now let us plot this quadrant system in 2-dimensional orthographic view. So we'll be plotting this quadrant system here in 2-dimensional orthographic view. So let us draw this 2-dimensional orthographic view of this quadrant system. So as you can see, this is your horizontal line, which is nothing but your horizontal plane, specifying your horizontal plane. This is your vertical line, which is at 90 degree to your horizontal plane. As we know that this must be your vertical plane because it is perpendicular to your horizontal plane. And by intersection of these planes, we are having the center point as your XY. And now due to this intersection, we are having 4 quadrants, namely first quadrant, second quadrant, third quadrant and fourth quadrant. Now always remember, we will be having object either placed in this first quadrant or second quadrant or third quadrant and fourth quadrant, and we'll be taking its front view from this observer direction here, and for top view we'll be taking the top view from this direction here. So we will be taking two views of any object. In our case, our object would be a point, so we'll be placing a point at any of the quadrants, and we'll be taking the view, front view from the observer direction, top view from the top direction. So now let us see. Now possible position of a point in space. So there are total 9 positions possible for any point in the space, which is listed down here. Now before going to that, let us understand the quadrant system quite differently. So now this is our quadrant system. This is your horizontal plane and this is your vertical plane. Now we will define this space above this horizontal plane. So the space above this horizontal plane would be known as above HP. The space below this horizontal plane would be known as below HP. The space in front direction of this VP will be known as in front of VP, and space behind this VP will be known as now behind VP. So for this we'll be having 4 quadrants once again: first quadrant, second quadrant, third quadrant and fourth quadrant. Now let us see. So we have total 9 position of any point. So first 4 positions we can define by 4 quadrants itself. So let us start with this first point. So this is your point A, which is placed in your first quadrant. Point B, which is placed in your second quadrant. We have taken this point C, which is we have placed on third quadrant. We have taken this fourth point, which is placed in fourth quadrant. So now let us define this point. So point A, for point A, we can say that point A is above HP and it is in front of VP. For point B, we can say that it is above HP and it is behind VP. For point C, we can say that it is below HP and it is behind VP. Point D, we can say that it is below HP and it is in front of VP. So you can see the description in red: above HP in front of VP, above HP and behind VP, below HP and behind VP, below HP and in front of VP. So these are first 4 positions of a point. Now let us define next 4 position of a point. So as you can see, the next 4 position would be lying in plane itself. So let us define first 4 positions. So we have first defined A, B, C, D. Now let us start with your point E. So as you can see, point E is here. So we can say that point E is in front of VP and it is resting on HP. So your point E is in HP itself. So we can see point E is on HP and in front of VP. Now after this point E, we will define point F. So point F is behind VP and it is in HP. So we can say point on HP and which is behind VP. Now next point is on VP and above HP. So we have defined this point G, which is above HP and on VP itself. So this is your point G. Next point H, which is on VP but it is below HP. So we can define on VP and below HP. Now let us define the 9th number point. So 9th number point would be at the intersection of your HP and VP. So as we can see, the intersection of HP and VP is nothing but your XY line. So 9th point would lie on this XY line. So let us define this 9th point, which is nothing but your point I, which is resting on HP and VP itself. So that means it is resting on HP as well as it is resting on VP. So we have defined here by on HP and on VP. So these are complete 9 positions of your point. So the possible position of point can be maximum of these 9 positions. So let us check out these 9 positions separately. So in this we'll be having one point A, which will be placed in the different quadrants, and its front view and top view are brought in same vertical plane for observer to see it clearly. Now as we know that front view is visible view on VP, but as the top view is a view on HP, it is rotated by 90° in clockwise direction to bring it in the same vertical plane. So now in procedure, the in front part of the HP comes below your XY line for the first and fourth quadrant, and the part behind VP comes above your XY line for the second and third quadrant. So let us observe and note the process. So let us start. So now we'll be talking about first quadrant first. So as you can see, this is our first quadrant. So our point A is in now first quadrant. So let us take this point A here. Now, as you can see, point A is above HP and it is in front of VP. So now we will take its two view. First is your front view and second would be its top view. So let us take its front view. So this is your observer direction. So we are observing this point from this direction. So if we observe this point from this direction, we will be having its front view somewhere here on the VP. So it can be known as your A dash point. So we have taken this point. So this is nothing but your A dash point. Now let us take the top view from these directions. We are taking the top view from this direction. So we can have its top view on this horizontal plane somewhere here. So we'll be having its top view here on your XY line. So this is nothing but your top view, and top view is denoted by small a. Now, as we know, we will be rotating this HP in clockwise direction by 90 degree. So our point A would actually lie on this vertical line somewhere here. So let us rotate this HP by 90 degrees. So we'll be having this point. This is nothing but your point A on the vertical line itself. So these are nothing but your A dash and A, which are the projection of your point for first quadrant. Now let us take the similar case for the second quadrant. So this is your second quadrant. So we have taken the point in second quadrant itself. So second quadrant means above HP and behind VP. So this point is above HP and it is behind VP. So this is our point. Now let us observe it from this direction. So if we observe this point from this direction, so it will give us a front view somewhere here on the vertical plane. So we will be having the front view somewhere here on the vertical plane. And as we know, on vertical plane, we are having front view, which is denoted by A dash. Now, if we try to take the top view from this top direction, we can have this top view on horizontal plane somewhere here. So let us take its top view. So top view would be lying on this horizontal plane somewhere here. This will be your point A without any dash. Now we know that we'll be rotating this horizontal plane 90 degree in clockwise direction. So let us rotate this plane 90 degree in clockwise direction. So our A point would lie on this vertical line, same vertical line of A dash. So our A point would be somewhere here. So as you can see, its front view and top view in the second case would lie on the same vertical line above your XY line. Now let us understand this case for the third quadrant. So for third quadrant, let us select any point A. So for third quadrant, point would be below HP and behind VP. So let us see, this is below HP and this is behind VP. So this is your point in third quadrant. So we'll be observing it from this front view direction. So we can have its front view somewhere here on the vertical plane. So front view is known as A dash. So let us define this point A dash on this vertical line. This is your point A dash. Now, if we take the top view from this direction, so we'll be having top view somewhere here on the line. So let us define top view on this line. So this will be your point A. Now we know that we'll be rotating this horizontal plane by 90 degree clockwise direction. We will have this point A on this line somewhere here. Let us rotate this plane by 90 degree direction and try to get this point A. So this is your point A. So as you can see, for third quadrant point, we'll be having its top view above your XY line and front view below your XY line. Now let us look for the fourth quadrant. So this is nothing but your fourth quadrant. So whenever your point is in fourth quadrant, so this is your fourth quadrant point. Point must be below HP and in front of VP. So this point is below HP and it is in front of VP. So this is your point A. Now let us observe this point from this direction, which is your observer direction. So we can have its front view somewhere here on our vertical plane. So we'll be having point A dash on this vertical plane. So this is your point A dash. Now, if we take its top view from this top direction, we can have its top view somewhere here on the horizontal plane. So let us take its top view. So our top view would lie somewhere here on the horizontal plane. After that, we know the procedure. We'll be rotating this horizontal plane by 90 degree clockwise direction. We'll be getting the final point A somewhere here on this vertical plane. So we'll be having this point A here. So as we can see in the fourth quadrant point, we can have both the views, front view and top view, both below your XY line. Now, in examination, what we have to do, we have to just simply plot our position of point with respect to XY line only. So this is the case we have to plot in our examination. So let us start with this point A in the first quadrant. So as we know, first quadrant point, that means our point would be above HP and in front of VP. So as we have seen previously, so we'll just draw the final projection of that point. So first we'll draw one horizontal line, horizontal XY line, and we know that for first quadrant point, its front view would lie just above your XY line and its top view would lie just below your XY line. So front view is nothing but your A dash point. So you will draw your A dash point above XY line and your point A would be below XY line. So here it is said that front view is above XY line. That means your A dash point would be above XY line and top view would be below XY line. That means your point A without any dash would be below XY line. Now let us see for point A in second quadrant. Point A in second quadrant means your point would be above HP and behind VP. So then you will be having its answer as front view above XY line and top view above XY line. That means you are having two of its views above XY line. So you will simply draw your XY line and you will draw two of its views, A dash and A, both above XY line. Now, for point in third quadrant, so we know that point, if your point is in third quadrant, that means it would be below HP and behind VP. So now if your point is below HP, that means its front view is below XY line. That means A dash would be below XY line, and behind VP, that means you will be getting its top view above XY line. That means your point A without any dash would be above XY line. So let us draw first XY line. You will be plotting one point A or top view above XY line, and on same line you will be plotting A dash or your front view below your XY line. Now for fourth quadrant point, so for fourth quadrant point, we know that if the point is in fourth quadrant, that means point would be below HP and in front of VP. So if your point is below HP, we'll be having its front view below XY line. That means A dash would be below XY line, and in front VP, that means we'll be having its top view below XY line. That means A below your XY line. So we are having two of the points below XY line. So let us first draw XY line, and we will be plotting 2 points A and A dash both below XY line. A means its top view or plan, and A dash means its front view. So we have to draw in examination these as our final figures. Now let us move ahead. Now we'll be defining 4 more points. So let us see 4 more points. So now point number 5. So now point now is resting on HP itself. So the point is now in HP itself. So we'll be taking its front view from this direction. So if we try to observe the front view from this direction, it can have its front view on this vertical plane. So vertical plane is nothing but the intersection point in this case. So our front view A dash would lie somewhere on this intersection point. So it will be your A dash. Now if we try to observe the top view from this top direction, we can have the point A somewhere here on this line itself, because your point is already on HP. So that means we know that the top view always lies on HP. So that means your point and your projection of top view would lie on the same point. Now we know the next procedure will be rotating this horizontal plane by 90-degree clockwise direction. So we'll rotate this plane by 90-degree clockwise direction. So now your point A would rotate from this point A towards in clockwise direction. So we'll be having this point A somewhere here. So this is nothing but a projection of a point whenever your point is resting on HP and it is in front of your VP. So this is the condition. Now let us see one more case. Now in this case, our point would lie in VP itself. So our point is above HP and on VP. So this is our case. So if we try to observe it in from front view direction, so if we try to take the front view of this object, so as we know, if we try to take the front view, so it will lie on the same vertical plane at the same place. So we'll be having A and A dash at the same place, because we know that front view always lies on the vertical plane. Now let us take its top view from this direction. So if we try to take the top view from this direction, so it will lie somewhere here on HP. So if we try to take the top view of these points, it will lie somewhere here on the intersection of HP and VP. So this will be your top view, and top view is nothing but your point without dash. So this is your top view. So for this case, you will be having your point top view on your XY line itself, and A dash would be above your line. Now let us take third case. In third case, our point would be resting on HP once again. So our point is now behind VP, but it is resting on HP. In first case, it was in front of VP and it was resting on HP. In this second case, our point is now lying on HP, but it is behind VP. So now let us observe this from this direction. So we'll be having its front view somewhere here on this vertical plane. So let us take its front view. We can observe this front view somewhere here on this line. And if we try to take its top view, we'll be having top view same as your point A. We'll be taking top view at the same point, and now we know the procedure. We'll be rotating this plane 90° in clockwise direction. So if we try to rotate these planes, we'll be having its top view somewhere here as point A. So let us obtain its top view somewhere here. So this will be your point A. So whenever your point is resting on HP and which is behind VP, so you will be getting A dash as your front view on your XY line itself, and point A or any planned point A would be above this A dash point. Now let us observe the fourth case. So fourth case would be your point is resting now in VP, but in this case your point is below HP and resting on VP. So now let us observe this point from this direction. So if we observe this point from this direction, so we can have its front view. So we know that front view always lies on this vertical plane. That's why we'll be getting A and A dash on the same point. We'll be having A and A dash at the same point. Now let us observe it from top. So if we try to take the top view, we can get the top view at the intersection of this HP and VP. So let us obtain its top view. So if we try to obtain its top view, it will be a point which is the intersection of your both the planes, because we know that top view always lies on the horizontal plane. So this will be your point on the horizontal plane. So now these are the four cases we have learned. First, point A is in first quadrant, in which point is on HP in front of VP. So this is on HP in front of VP. Point in second quadrant, but it is above HP and on VP. So point is above HP and on VP itself. Third case, in which the point A is in third quadrant, which means we are having point somewhere here, but on HP and behind VP. So it is resting on HP and which is behind VP. And last case, which is point is in fourth quadrant, but below HP and on VP. So it is below HP and on VP itself. This is your point A. So now in examination, we'll be plotting these points in two-dimensional figures with respect to XY line, just what we have done previously. So let us denote these things. So if your point A is in first quadrant, means in this case on HP and in front of VP, you will be having front view on XY line. That means A dash on XY line, and in front of VP, that means top view below XY line, which means point A below your XY line. So we'll be drawing point A dash on XY line and point A below your XY line. Now for second condition, point A is in second quadrant. So that means in this case, point would be above HP and on VP. So we'll be getting as answer front view above XY line. That means our A dash would be above XY line and top view on XY line. Top view means point A on XY line itself. So we'll first draw our XY line and we'll first plot point A on XY line as it is said. And second, front view above XY line. So that's why we'll be plotting this A dash above this XY line. Now next, if your point A is in third quadrant, that means your point in this case would be on HP and behind VP. So on HP, that means our answer would be front view on XY line. Front view, that means A dash on your XY line. And behind VP, that means our answer would be top view above XY line. Top view means A point above XY line. So let us first plot your XY line as it says that front view on XY line. That means we'll be plotting this A dash as a front view on XY line, and from that we'll be plotting this top view just above this point A dash, which is your top view above XY line or your point A above XY line for the third quadrant. Now let us understand for point A in fourth quadrant. So if your point A is in fourth quadrant, so for this case point would be below HP and it is said to be on VP. If your point is below HP, we'll be having our front view below XY line. Front view means your point A dash below your XY line, and on VP, that means our top view will be on XY line. That means top view means your point A would be your on XY line point. So let us start. So first we'll be drawing this XY line first. Now as it said, front view is below XY line. So we'll be drawing the front view below XY line, which is your A dash point, which is your front view point below XY line. and top view would be on XY line. So that's why we'll be plotting its top view, that means point A on this XY line. So it is very simple. Now, after observing these cases, we can obtain one table. It is known as projection of points table. This table can be further subdivided into two tables. This is your first table, which is having points with respect to HP, and the second table we are having point with respect to VP. So now let us understand this table. So in example, it must be given point A above HP. So you will be getting A dash as your resultant. A dash is nothing but your front view or your elevation above XY line. Now if it is said that point A is on HP, you will be having answer as your point A dash on XY line itself. Now it is said that point A is below HP. You will be plotting your A dash below your XY line. Very simple. Now let us understand second table. So in second table, the point with respect to VP would be given. So let us see. The location of point A is in front of VP. That means your answer would be A. That means plan or your top view below your XY line. Now it is said that point A is on VP. That means you will be plotting point A on XY line itself. Now if it is said that A point is behind VP, you have to simply plot your A point without any dash above your XY line. Very simple. So try to memorize this table and you can solve any example very easily. So now let us see one example and try to apply this table here. So projection of points, draw the projection of following points. So we are having total 9 points and we have to plot these 9 points on same single XY line. So let us start with the first point here. So first, point A is 40 mm above HP and 55 mm in front of VP. So let us understand point A means obviously we'll be having two projections, A dash and A as our answer. So we'll be having A dash and A as our answer, which is nothing but your projection of that point A. Now let us start with first statement. 40 mm above HP and 55 mm in front of VP. As you can see, we are having data with respect to HP and with respect to VP. So we remembered our table. So we are having two tables, one respect to HP and another respect to VP. So now let us go to the table and solve the example. So here it is said that 40 mm above HP. So let us see our table. So here it is said that above HP, so your point is above HP. So you will be having your answer A dash, and which will be above your XY line. So let us move ahead. So 40 mm above HP, that means you will be plotting this point A dash above your XY line and it is by 40 mm. So you will plot this point from this XY line 40 mm above and this will be your point A dash. You will mark it by a dark point. Now 55 mm in front of VP. So let us look our table for VP. So here it is said that if your point is in front of VP, we have to plot point A without any dash below your XY line. So let us plot this point. So it is 55 mm in front of VP. So we have to plot this point 55 mm below this line, XY line. So we'll be marking this point as your dark point, which is nothing but your point A, which is 55 mm below your XY line. Now let us apply the procedure similarly for 9 of the examples. So point B, 10 mm above HP and 25 mm behind VP. 10 mm above HP, so let us look at the table. 10 mm above HP, that means our answer would be A dash above XY line. So we'll be plotting this point B dash in this case, and which is 10 mm above this XY line. This is your point, dark point B dash. Now it is said that 25 mm behind VP. So let us look the table for VP. So if your point is behind VP, you will be plotting this point without any dash above your XY line. So let us plot this point, which is 25 mm behind VP. That means your point answer would be 25 mm above your XY line. So we have plotted this point, which is blue point, and which is your nothing but your point without dash. In this case, our point is B, so we have used B in this case. So this is your B and B dash. Now let us solve the example for third case. Now point C, 35 mm below HP and 20 mm behind VP. So 35 mm below HP, so we'll be having A dash point below XY line. So we'll be drawing this point C dash in this case, 35 mm below XY line. This will be your point C dash below 35 mm below XY line. and it is said that 20 mm behind VP. So let us see 20 mm behind VP. That means point A would be 20 mm above XY line. So we'll be plotting this point, in this case C, 20 mm above this line. This is your point C, which is 20 mm above your XY line. Now for point D, fourth number example, point D, 10 mm below HP and 40 mm in front of VP. 10 mm below HP, that means if your point is below HP, we will be plotting A dash below XY line. So let us plot this point 10 mm below HP. So we have plotted this point D dash, which is your red point, 10 mm below your XY line. Now 40 mm in front of VP. So we'll look for the table in front. So in front, that means our answer is A without any dash below your XY line. So let us plot this point 40 mm in front of VP. That means 40 mm below your XY line. So we have plotted this point 40 mm below this XY line. This is your point blue, and blue point you will denote it by your point D. Now let us solve for point E. Point E is on HP and 50 mm in front of VP. So on HP. So let us see if your point is on HP. So our answer would be A dash on XY line itself. So now let us see. So we'll be plotting this point E on HP, that means on XY line itself. So we have plotted this point E dash on XY line itself. Now 50 mm in front of VP. So it is with respect to VP. So we'll look for the table of VP. So in front of VP, that means we'll be having without dash point below your XY line. So let us plot this point, which is 50 mm in front of, that means 50 mm below your XY line. So this is your point without any dash, and which is your blue point 50 mm below your point E dash. Now let us solve example for point F. Point F is on HP and 80 mm behind VP. So on HP, let us see on HP, that means point would be A dash and on XY line. So in this case, our point would be F dash on your XY line. Now it is 80 mm behind VP. That means we have to see for the table of VP. If your point is behind VP, we'll be having point without dash and above XY line. So here it is said 80 mm behind VP. That means our point would be 80 mm above XY line, and this point would be without dash, and this is your point in blue, and this is your final point or the final top view, or it's your plan. Now point G on VP and 75 mm above HP. So that means on VP means on XY line from the previous table. So we can see on VP means on XY line. So we have drawn this point G on VP, that means on XY line, and it is 75 mm above HP. So let us see the table for HP. So above HP, that means our point A dash above XY line. So now in the case of point is 75 mm above HP, that means we will plot point G dash 75 mm over your XY line by a red point. So this is your point G dash, which is 75 mm over your XY line. Now point H on VP and 30 mm below HP. So on VP and below HP. So on VP, that means we will be having point without dash on XY line, and below HP, that means we'll be having A dash below your XY line. So let us plot this point on VP. That means we'll be plotting this point H on this XY line itself, and it is 30 mm below HP. That means below HP, that means below your XY line, and we'll be plotting its dash point below this XY line, which will be 30 mm below this XY line. Now for the 9 point, point I is on both HP and VP. That means let us see. If it is on HP, then we'll be having A dash on XY line, and if it is on VP, then point A would be on XY line. That means we can see both points would lie on XY line itself. So now here in this case, we are having this point I. That means your I and I dash point both would lie on the same XY line, like this figure. So this is your point on XY line. This is your dark point on XY line. You will specify it by I dash and I. So this is your first example. Now let us look one more example. So draw the projections of a following points on a common reference line, keeping the distance between their projectors 30 mm apart. So we are having total 4 points, and projectors means for point A, projectors would be A dash and A, and for point B, projectors would be B dash and B. So while drawing these projectors A dash and A line and B dash and B line, so we'll be keeping the distance between these two projectors as 30, as you can see in this figure. For next two projectors B dash B and C dash C, will be keeping this horizontal distance 30, and for C dash C and D dash D, we can keep this distance at 30, as it is said in this example. Keeping the distance between their projectors should be 30 mm apart. That means you will be plotting each of the examples by 30 mm distance apart. So now let us start with the first example. Point A is 20 mm below HP and 55 mm in front of VP. So we'll be using the same table once again. 20 mm below HP, that means if it is your point below HP, then we'll be having answer dash below XY line. So 40 mm below, so now let us see 20 mm below HP. That means we'll be plotting one point 20 mm below XY line, which is your point A dash. Now, if your point is 50 mm in front of VP, in front, that means we'll be using this table of VP. So in front, that means point A would be below your XY line. So let us plot this point A, which is 50 mm below your XY line, and we'll denote it by point A. So this is your 50 mm in front of VP. Now, point B is in HP and 40 mm behind VP. So let us use the table in HP, that means on HP. So on HP, that means we are having A dash on XY line. So point B would be resting on XY line itself. So this is your point B dash on XY line itself. Now 40 mm behind VP, 40 mm behind VP, so we'll be using this table of VP. So our answer would be without dash point above this XY line. So now we'll be plotting this 40 mm above this XY line and without dash points. We'll be plotting this 40 mm point above this XY line, and this point would be without dash point. Now let us solve the third case. Point C is 30 mm in front of VP and in HP. So 30 mm in front of VP. So let us use this table. So in front of VP, then you will be having without dash point below this XY line. So in this case, 30 mm in front of, that means we'll be drawing 30 mm below this XY line, and this will be without dash point 30 mm below this XY line. So this will be your point C. Now it will be N in the HP. In the HP means on HP itself. So point A is on HP. That means we'll be getting this dash point on XY line. So in this case, point is C. So we'll be plotting this point C dash on this XY line because it is in HP. So we'll be plotting this C dash on your XY line. Now let's solve the example for fourth case. Point D is 50 mm above the HP and 30 mm behind the VP. So let us use this table above HP. That means we'll be having point above HP. That means our answer would be dash point above XY line. So in this case, 50 mm above, that means we'll be plotting 50 mm above XY line, which is your point D dash, which is 50 mm above XY line. And now it is 30 mm behind VP. So let us look at the table. So A point is behind VP. So answer would be your point without dash above your XY line. So now 30 mm behind, that means 30 mm above your XY line without dash point. So let us plot this point without any dash, 30 mm above this XY line. So this will be your point D. And as it is said, you have to draw all the projection on common reference line, keeping the distance between the projectors 30 mm apart. So we have kept the 30 mm distance horizontally between each of the projectors of the ABCD points. Now let us look one more example. It's a different type of an example. So let us look. A point P is 50 mm away from both the reference planes. Here the both the reference planes means HP and VP. Draw its all possible projections. So here they have not specified which projections you have to plot, but you have to just identify these projections, how many projections is first possible for this point, and then after you will start projecting. So here our point P is 50, 50 from HP and VP, both the planes. Now hence the possible positions would be point P in all the four quadrants at 50-50 distance from your HP and VP both. Now using our previous rules or our tables, we will get following projections. So now let us start with the answer. So now first we'll be plotting this XY line. So now let us first project this point P according to your first quadrant system. So first quadrant point would be above XY line and it is in front of your XY line. So above XY line, that means point would be above HP, 50 mm above HP and 50 mm in front of VP. So if your point is 50 mm above HP, so we'll be using the table above HP. That means we'll be plotting A dash above your XY line. So we'll be plotting this point P dash above your XY line, and the distance would be in this case would be common, which is 50 for all of the examples, as you can see. So we'll not bother about distances. So we'll be plotting this point P dash 50 mm above your XY line. Now in first quadrant, point would be in front of VP. So in front, that means we'll be having the point A below your XY line. So the first quadrant point would be without dash and which will be below your XY line. Similarly, as we have seen in previous figures, for second quadrant, we know that both the points would lie above your XY line. So we'll simply plot both the points 50 mm above your XY line, which is your point P dash and P for your second quadrant figure. Now for third quadrant, we have seen that our point top view or without dash point would lie above your XY line, and for third quadrant, our P dash point would lie below XY line whenever your point is in place in third quadrant. So third quadrant means point would be below HP and behind VP. So if we apply the theory for your third quadrant, so point P would be 50 mm above your XY line and point P dash would be your below XY line. Now let us take the fourth point in the fourth quadrant. Fourth quadrant, that means your point is below HP and in front of VP. Below HP, that means our A dash, or here in this case of P dash, would be below XY line. And if your point is in front of VP, that means in front, that means as you can see below XY line without dash point. So for this case, point P would be also below your XY line, and the distance is common for all the cases, which is 50. So in this case, we have used the first quadrant, point is in first quadrant. For second stage, we have used the point in second quadrant. This is your representation for point in second quadrant. This is your third quadrant, in which your point is below HP and behind VP. And this is your fourth point, which is in fourth quadrant, which is below HP and it is in front of VP. Now, so we have to remember this table. Once again, I will say you have to just remember this table.